Hello everybody, I am Rajendra Kulkarni. Welcome to my channel Programming in C with RSK. In this video, I will be explaining for loop in C programming. How to use for loop for C programming. Let us start with a simple program which will explain us how to construct a for loop. Int I declared one variable int I. Then there is a statement which starts our for loop. For into the bracket I is equal to 0 semicolon I less than 5 semicolon and I plus plus bracket closes. The opening loop of the opening braces of the loop, a small printf statement, printf I is equal to %di. So in every iteration of the loop, this statement will get executed. Closing brace of the loop, and when the program comes out of the loop, another statement, small simple printf outside the loop I is equal to %di, closing brace of the main. While using for loop, the first thing that is appearing in the for loop is I is equal to 0, I being the counter or the test variable, its initialization, then semicolon, then I less than 5, another semicolon, and I plus plus. So this is the initialization, this is the incrementation operator, and this is the condition test. On reaching the closing brace of the loop, the program modifies the value of test variable by this statement I plus plus. So when the loop reaches at this place, the program reaches at the closing brace, goes back, increments I, and then it tests the condition, evaluates the expression, test expression. When expression is true, or the expression evaluates to true, program continues in the loop. Once the expression I less than 5 evaluates to false, program comes out of the loop and starts operating or executing the statement outside the closing brace of the loop. Initialization I is equal to 0 executes only once when the program enters into the for loop. When the expression I less than 5 or any expression which we put here in our loop, in the loop, in this case it is I less than 5. When I less than 5 is non-zero, the statements within the curly braces will get executed. When the program reaches the closing brace of the loop, it will go back, increment the test variable, evaluate its expression. If the expression becomes true, again the statements are executed within the loop. Once the expression becomes false, the condition becomes false, program comes out of the loop. The output, in every iteration when I is equal to 0, this printf statement gets executed, program reaches the closing brace, goes back, I becomes 1, I plus 1 causes I to have a value of 1, again evaluated, executed the statement within the closing and opening braces of the loop. This continues, these iterations continues till I less than 5 becomes or evaluates to 0 or false. We can also use char variable as our test variable. In this program, what we are doing is using char variable ch in the expression to evaluate the condition of true or false. There is one variable int j, another variable char ch, then our loop, for loop, into brackets ch is equal to a, comma, j is equal to 0. We can have 2 or 3 or as many initializations in this first initialization part of the loop. Ch not equal to d, within the semicolons, then ch plus plus and j plus plus. Again we can have as many variables incremented here as we want in our program or in our loop. When the for loop's condition is true, it will enter into the loop will start executing, iterating. Here we have only one statement to be executed in the loop, which is a simple printf statement which displays the values of ch and j onto the monitor screen. Since only one statement is to be executed in the loop, there is no compulsion to use opening and closing braces. Braces are not required. If we put it, it's well and good. If we don't use those, it's okay. So the loop will continue operating till ch does not becomes or equals d. Once the ch is equal to d, because we are incrementing ch in every iteration, the loop terminates and the statement printf out of the loop ch is equal to %c, j is equal to %d, ch, comma j. This statement will get executed and the program will end. This is the closing brace of the program. What will be the output? First of all, there will be 3 statements or 3 outputs for 3 iterations. Inside for loop, ch is equal to a, j is equal to 0, 1, 2. When ch becomes c, the third iteration, ch is equal to c, and the fourth iteration, when ch becomes d, the program comes out of the loop and loop terminates. Another way of using for loop, j is equal to 0. In this example, what we are doing, we are just putting a comparison expression, no initialization, no incrementation or no change in test variables value. Opening brace, what we have done is we have initialized j is equal to 0 before the loop starts. Within the loop we are incrementing j. So initialization we have done earlier, incrementation we are doing within the loop. Until j is less than 5 is true, the loop executes between all the statements between the closing and opening and closing braces of the for loop. Output is j is equal to 0, 1, 2, 3 and 4. A slight complexity in a program. In this program, what we want to do in this program is we want cosine of the angle. First of all, angle in degrees is 0. In the program we are incrementing this angle in every iteration by 30 degrees. So initialization is absent because angle underscore d is equal to 0 is already initialized. No need to initialize it again here. But if we want, we can do it, no issue. In the comparison or the test expression, what we are testing is whether angle underscore d is less than or equal to 180. Till the angle is 180, the loop will execute. On reaching 180, when the angle exceeds 180, the loop will terminate. And another condition we are using is whether c is greater than 1.0, where c is the cosine of the angle expressed in radians. In this statement, c is equal to cos and into the bracket radian. In this part of the for loop, where we were earlier using, in the earlier two programs we have used incrementation operators. Here instead of that, what we are using is we are converting angle in degrees into radians by going through this formula, where m underscore pi is the pi value which is defined in the file mat.h, which we have included in our program. So what is happening in this part of in this expression, the angle in degrees is getting converted to radians, its equivalent radian value. Since angle underscore d is 0, it is less than 180, the loop starts execution. Opening brace of the loop, c is equal to cosine of rad, where rad is angle in degrees converted to radians. Rad is a float variable we have declared. C is a float variable we have declared. So whatever may be the value of this expression, cos into the bracket rad, whatever this function gives the value, that get assigned to C. In the next statement within the loop, we are just displaying the values of the angle in degrees in every iteration and its corresponding cosine value. Look at the format string here, percent 1.2f. This 1.2 causes the float value of cos to be displayed only up to the two places after decimal point. So point 2 tells the compiler to display the value of the float variable up to the second decimal point only, up to the second place after the decimal point. In this statement, angle underscore d is being incremented by 30 in every iteration, closing brace of the loop, till this angle underscore d less than or equal to 180 is true. Loop goes on executing, giving the value of cosine of angle underscore d, which is getting incremented by 30 in every iteration. When the angle goes more than 180, when the angle underscore d reaches more than 180, loop terminates, program comes out of the loop and ends at the closing brace of the main. Initialization here not mandatory, expression is allowed here. We can have two or more expressions into the between the two semicolons, but they must be interrelated with some kind of operator. Here we are using OR operator. Output of the program, angle in underscore d, angle in degrees, it starts with 0, goes on incrementing by 30. When the angle becomes 180, when it increases, it reaches to more than 180, loop terminates, and these are the values given by cosine function which are displayed on our screen. Then there are a classic example of nesting of the loops. We are going to see in this program how nested for loop works. It's applicable mainly when we will see the arrays and functions. Here we are just writing a small program which will give us a better information and understanding of the nested loops. We have initialized, or we have declared three variables, int variable ijk in the first loop. The for I is equal to 0, I less than equal to 1, I plus plus. This is our for loop, which is the outermost loop. Then the opening brace of the loop. Then there is a printf statement. This /t causes the output from this printf at every time it operates, it gives the output with tab. Then another loop, j loop, for j equal to 0, j less than equal to 1, j plus plus. Another opening brace of the j loop and a printf next line statement, new line statement. Third loop, innermost loop, k loop for k is equal to 0, k less than equal to 1, k plus plus. In this loop we are giving a output statement, printf statement for indicating output. Printf I is equal to %dj, k and I. So it will tell us what is the value of I or j or k when the loops are in execution. This is the closing brace of k loop. This is the closing braces of j loop. This is the closing braces of I loop and the closing braces of main. Here the main closes. So what we have done here is we have first declared one loop, we have first programmed one loop. Within that loop we are again programming second loop. Within that second loop we are putting third loop, and then when we execute this program, what is the output we are getting? First I is equal to 0, there will be a tab, this then for this print a tab giving us a good space between the display of various variables. For j is equal to 0, again a printf next line new line statement, and for k is equal to 0, this loop will get executed first. For once for k is equal to 0, when the program reaches the closing brace of the loop, it will go back again, increment k by 1 and executes printf I is equal to %dj, k and ijk. When k becomes more than 1, loop terminates and comes out, the program control comes out of this closing brace. It reaches this closing brace of j loop. At the closing braces of j loop, it will again, the program control will go back to this statement for j is equal to 0. There j will be incremented. Since j is less than or equal to 1, again this loop will start executing. The k loop, k initialized to 0 because we are entering into the k loop from this point. K initializes to 0. K loop executes for two values of k, 0 and 1. Again when k loop terminates, we reach into the j. For then for j is equal to 1 starts executing. When the j loop ends, its closing braces are reached. There is a closing braces of I. So program control go back to I loop for I is equal to 0. There again, since I was earlier 0, now it will be incremented to 1. Since it is 1, I less than or equal to 1 is true, the whole program will again get, all the loops will again get iterated, and when I reaches more than 1, the loop closes, I loop closes, program comes out of the I loop. Then there is simply a closing brace of main. So we get the output I is equal to 0. At that time, when I is equal to 0, j is equal to 0, k is equal to 0 and 1. Once the program comes out of k loop, it goes into the j loop, j becomes 1. Again k is equal to 0, k is equal to 1 get executed. Then program comes out of the j loop, goes into the I loop, I becomes 1, and again the iteration starts. So outermost loop iterates 2 times. For I is equal to 0 1 time, for I is equal to 1 This is the second iteration. Intermediate loop iterates 4 times. J loop will iterate 4 times. First for j is equal to 0, then j equal to 1, for I is equal to 0, and then again for I is equal to 1, j is equal to 0, j is equal to 1. And innermost loop, the last loop, the k loop in this case, it will iterate 8 times. So this is how nested loops work. Friend, this is the 9th video on the channel for C learners. Please like my videos, subscribe to my channel, and share it with your friends. Thanks for watching.